Project 6 is on a test called chi-square, and there's 3 parts to it. The first part here shows a table, and again, this is just a frequency table. This is not a contingency table, with some information given about the flavor blend for the Skittles candies. And what you'll see here is a listing of the different colors that are in 5 different bags. So we have bag 1, 2, 3, 4, and 5. These are all separate bags. And in bag 1 you have 7 green Skittles and 20 orange and 10 red, 7 purple, and 14 yellow, and so on. So when you evaluate these and you do the chi-square goodness of fit test, you're looking at each bag separately. So if we took that first bag, we would have to count these all up. So you'd have to add these all up and you get 58. And then you would have to compute your expected value. So you're given here the observed values. Then you have to make a little table, which would be a 2x5 table of expected values. And then you want 20% of each. So 20% of 58 would be 11.6. So you would actually expect 11.6 green in the first bag, 11.6 orange, 11.6 red, 11.6 purple, 11.6 yellow. So basically what you're doing is now seeing that is that difference that's listed here significantly different. So that's what that goodness of fit will test. And these questions you'll answer based on your results. To those, you have to run 5 separate goodness of fit tests. So you'll have 5 separate 2x5 tables. And then for the second part, you don't have to compute anything. And what you have to do on the first part here is a lot of you that have the TI 8384 calculators, this is one of the tests that it won't do. Now some of yours will, some won't. But if you look in your text, it's a very simple computation by hand. Now in part 2 of Project 6, you'll see that you're given the output. So everything's here. You just have to answer the questions. And we'll go down to these questions. For example, which number from the output is compared to the significance level, to check to see if you should reject. Well, that's your p-value. So you compare your p-value to the significance level. If your p-value is less than the significance level, then you would reject. And you'll notice in this case, this is 6%, this is 5%. And then you'll continue to answer these questions based on this information. Now some of these are in your book. For example, does increasing sample size change the degrees of freedom? And the answer to that is no. No, chi-square degrees of freedom is not affected by sample size, but by the size of the table. So this is a 3x4 table. That means that 2 times 3, or 6 degrees of freedom. So row minus 1 times column minus 1. And number 8, for example, does chi-square tell you which cells observed and expected frequencies are significantly different? And no, it just tells you basically, is there something in the whole table that we need to further investigate? If you reject, you're going to say, well, we're rejecting the entire table. Not any specific instances, even though you may talk about some big differences that would occur between the observed and the expected values. Now, for the part 6, you have to take these and create 2 tables. You're going to have a 2x3 table. And here it's giving you information, male, female, for your row variables. And then your column variables will be less than 20, 20 to 50, and greater than 50. So you're going to actually create a table and count up how many males were less than 20 and put that count in the table. How many males were 20 to 50 years old and how many males were greater than 50. And you'll create those tables. And then in the second part, you'll do the same thing. You'll have 2 rows, males and females, and you'll have 1, 2, 3, 4 categories then. And then you'll compare the results. You'll see that they will be different from each other. So just by changing those columns, they'll be different.